Okay, we're talking about light. Make sure that you leave space at the bottom of your notes for a summary. And we're gonna go on ahead and get started. First thing you need to know is light energy. I know we covered this already, but we're gonna do it again. So light is a form of energy that travels in waves. And we'll talk more about the waves and the wavelengths later. This is all visible light, every color in the rainbow. So we only see the color that's reflected back, which is why when we see an apple, for instance, we see red or green or whatever color apple you're looking at, because, there we go, because all light's hitting it at one time, but the color that is the strongest in that moment is going to be the red. So we only see what's reflected back. But if you have a prism, if we have white light coming in, when it comes out of the prism, you'll see a rainbow. And I'll show you what I'm talking about later on. Draw a quick little chart. We're going to talk about what happens when light hits an object. So light can do three things. We talked earlier about light bouncing off, or what bounces back at us. That's called reflection. So light can reflect or bounce off. The opposite of that would be for light to be transmitted or refracted. Which means it's going to pass through it. It can also bend the light, and I'll show you an example of that later. Our last thing that light can do would be absorbed, which basically just kind of like light being swallowed up or taken in. So let's talk a little bit more about the first two, reflection and refraction. First, we'll do reflection. Like we said earlier, a reflection is the bouncing back of light. For a quick example on paper, let's say you have a wall, or a mirror in this case actually. You're going to shine a flashlight on that mirror. So when your light goes out, it's going to go straight to the mirror because light travels in a straight line, and it's going to bounce right back. So not only are you going to light up things in front of you, but you're also going to light up things behind you. If you're, excuse me, if you're shining a light at that mirror at an angle, it's going to do the same thing, except it's going to bounce off in the opposite direction. So if you hold it at an angle, it's going to bounce off at an angle. If you hold it straight, it's going to bounce off straight. Either way, the light is traveling in a straight line. The opposite of reflection will be refraction. And that's going to be the bending or passing through of light. And typically this happens from one thing or material to another. For example, I'm going to shine a light straight through my prism here, and it should bounce off, if I can get the angle right, back onto the paper. And you can sort of see it shining down there at the bottom. So that light has gone through the prism. I'm holding it flat on the side here. I haven't moved it. Oh, I can't get, there it goes. And you can see it on the bottom of the paper. So my light is bending. It is passing through from the prism down to the paper. This often happens, or you can usually see it with water. So let's say you're out on your boat fishing. Yay, there's you. And you've cast your line down off into the water. It never looks like your line is going in the direct angle that you sent it out at. It tends to bend downwards. This is refraction. That light is bending once it hits the water down. Last two things we have to talk about are convex and concave lenses. We'll start with concave. So a concave lens is thin in the center. It's hard to tell with this one because it's thick on the outside, but it goes in towards the center. I'm trying to find a good angle to show you that. And it's thicker on the edges, so that's why you see the thick part of our edge, and it goes in. I'm sorry, I can't really show you that on here. Basically what you need to know is that this is going to bend the light inwards. So a spoon is a concave lens. When you look at your spoon, you see how small my dot is. This is also great for far-sighted people like me. In my glasses, you can kind of tell that they go in and then they come back out on each edge. See them push out a little bit on the front. This helps me to see because it's pushing the light inwards, which makes it much easier for me to read across the room because I am blind without them. Let me see if I can sort of give you that effect. There we go. Right now you're looking through the lens, it's pretty clear, and if I pull further away, and now it's all blurry again. By the way, this is sort of how people with glasses see. So right now it's extremely blurry, and the closer or the more I pull that lens in, the easier it is for you to see. So without my glasses, with my glasses. Let's draw a quick picture and we can move on. So our concave lens is thick on the edge, thinner in the center. Another example of a concave lens would be a spoon. Our last topic is going to be a convex lens. So a convex lens is thick in the center and thin on the edges, so the exact opposite. And instead of bending the light in, it's going to bend the light out. Just so we know, this is what that lens looks like a little bit. And so you can see the vision. I'm going to pull it up real quick. With the convex lens, or excuse me, without the convex lens, with the convex lens. And let me pull it up a little bit. Without. So when an eye is working properly, it's going to have the same shape as this convex lens, because your eye has a lens over it that looks just like this. No, I am not talking about glasses. Every single eye has this kind of lens inside of it. Now, some, like mine, are a little faulty, so we have to use a concave lens to see. Okay guys, when you are done, I want you to tell me the difference between reflection and refraction for your summary.